We have Heisenberg's uncertainty principle. Okay, the principle is slightly tricky to understand, but you know let's try to take key what were they trying to say when a basic introduction to quantum mechanics we will learn over here. Now, people, if you look at classical physics में हमने तीन फॉर्मूला पढ़ा है in classical mechanics. Can anyone give me the three formulas which Newton gave? First formula क्या था? V is equal to U plus AT. S is equal to UT plus half AT squared, and V square is classical mechanics. May using these three formulas, we can more or less define the motion of even heavenly bodies, motion of planets and stars and so on and so forth. For example, let's say कि I have a particle moving in some direction. Let's say इस direction में जा रहा है वो. I assume, let's say कि the particle was initially at rest. Initial rest मतलब initial velocity will be 0. Then the particle, let's say, is moving at an acceleration of 2 meters per second square. Okay. Can someone tell me if I want to, let's say, find what will the velocity be after 5 seconds? तो हम क्या करेंगे यहाँ पे people? V will be 0 plus acceleration was 2. Time कितना था people? So the velocity after 5 seconds would be 10 meters per second. ठीक है. I can also find the displacement. One dimensional movement भी देख रहे हैं. So I can also find the displacement of the particle. कैसे निकालेंगे? By the second formula. तो displacement क्या मिलेगा? S is equal to 0 plus half into 2 into 25. मतलब the displacement will be somewhere around 25 meters. However, when you try to apply the same formula to subatomic particles, then everything goes for a toss. अब classical mechanics के formulas subatomic particles को apply नहीं कर सकते. Let's try to understand why can't you apply classical mechanics formula to subatomic particles, because what we have assumed over here कि उनका एक ही nature है, that all these are only particles. For large bodies, you, me, table, chair, marble, wave nature is significantly small. वो हमने देखा था in de Broglie's wavelength. Lambda is equal to h over mv. तो m इतना ज़्यादा है that lambda becomes very, very small, because lambda is directly proportional to Planck's constant h, and Planck's constant value is 6.63 into 10 raised to minus 34. So the lambda for macro objects is so large that you can simply neglect these values. Subatomic particles में, however, क्या problem होता है? Let's try to understand that. Let's say कि I have nucleus, and how it was defined by Bohr, that I have an electron which is revolving around the nucleus in circular orbit, and यहाँ पे let's say I have the electron. Now, according to Niels Bohr gave us the formula for velocity, he gave us the formula for radius. If we know the direction of motion, if we know the velocity at which the particle is moving, I know the radius, I can exactly pinpoint where the particle is. But in order to find the particle, I need to use a scale or a ruler. For example, if I want to, let's say, decide the size of this stylus, इसका साइज कैसे डिसाइड करेंगे? I will use a appropriate ruler, I'll use a scale, I'll keep it next to it, and then I'll decide what is exactly the size. But let's say when you go to smaller and smaller particles, for example, I want to know the width of my hair strand. How do you calculate the width of that? Do you have a scale which is that small? No, you don't have a scale that small. What we do is we use light. Why we use light? Because we use the wavelength of light to measure extremely small particles. Now at the same time, let's say if I want to see where the electron is, if I want to know where the electron is, I have to bombard light on the electron. तो कहीं से I will have to bombard light on the electron, and when this reflected light is observed, then probably I can see the electron. It's as simple as this. The reason you can see me is because there's light which is falling on me. That light is reflecting back, and then you can see the colors, that everything that we see around, it's because of light reflected. Similarly, if you want to observe the electron, what you have to do is you have to incident light. Light is which is nothing but bundle of energy of photon that has to be incidented on the electron, and then you can observe the electron. But what is the problem here? The moment a photon collides with the electron will quickly absorb its energy, and हमने assume किया था, let's say that the trajectory of motion is this. But the moment the electron will absorb the energy, what will happen? Its original trajectory will change, and kahin pe then it will move in some other direction, because that absorbed energy will change its momentum. So for example, imagine this classroom to be empty. जो single chair, imagine that to be empty. And let's say imagine कि एक ही student यहाँ पे बैठा है, and that student is the electron. अब light falls on Gatik, reflects, and I can see that he's sitting over there. But subatomic particle में ऐसा नहीं होगा. The moment light will fall on him, let's say he's an electron, and will reflect back. Him being the electron, he will quickly absorb the energy from that photon, and his position will change. Somewhere on कोई अलग row में, किसी अलग bench में, I don't know where exactly, but his position. Hence the reflected light will tell me कि अरे गतिक यहाँ पे है, but in reality is he over there? No, he's probably in some other. And that difference is called as uncertainty. I repeat, Gatik, let's say, was here, and when the right light reflected, he will absorb the energy और वो shift हो गया यहाँ पे. ये difference को हम बोलते हैं uncertainty in position. You cannot accurately determine the position of subatomic particle or its velocity simultaneously. You can only determine one of the two. If you try to determine the position of an electron, its velocity will go for, its momentum will be uncertain. Uncertain मतलब error भी बोल सकते. There will be a large difference in its actual momentum. Vice versa, if you try to calculate the momentum of an electron, there will be large uncertainty in its position. Let's try to take some real life example to demonstrate this. I think example हमने पहले भी लिया था, but let's take this example. Let's say I want you to click a picture of me, but वो picture में I'm moving my hand. Let's say when you click a picture, where will my hand be? वो ऊपर आएगा या नीचे आएगा? Can you determine the exact position in which you can determine? No. Why? Because let's say if I am moving my hand and आपने click किया, and let's say the position is over here, but was it the actual position? Because that position quickly changed. That uncertainty or that error is what the uncertainty principle says. That you can define कि हाँ the hand का motion is in particular area. Where exactly in that area? You cannot really define that. This is Heisenberg's uncertainty principle. Whenever you try to find the exact position, उसका momentum goes for a toss, and vice versa. When you try to find momentum, there is an error, there is an uncertainty in position. Did you people get that? Yes or no? Chalo. On a new page, please write down Heisenberg's uncertainty principle. Let's do. Heisenberg's uncertainty principle. States that Heisenberg's uncertainty principle states that it is impossible to measure simultaneously the exact position and momentum of a body as small as an electron. As small as an electron. Next point. Heisenberg rules out the existence of definite path or trajectories of electron and other similar particles. I want you to understand this statement again, people. So what we have learned till now, that electrons revolve around the nucleus in circular or in elliptical orbits. That is not the case. There is no orbit. There is no trajectory. I repeat. अब तक क्या बोलते थे? The center of the atom there is nucleus, and revolving around the nucleus are electrons. In which orbits? Circular or elliptical orbits. Actually बाद में prove किया था it is elliptical. But quantum mechanics says that there is no orbit, there is no trajectory. Rather, if you want to visualize how an atom is, let's say you want to visualize how hydrogen atom looks like. Imagine this room to be spherical. Okay? Imagine center of the room. There is a dark football, center of the room floating. Dark black, imagine karo, center of the room floating and revolving around its own axis. Now, hydrogen atom, one electron. Imagine that one electron to be similar to Harry Potter में there is a snitch. वो Quidditch game में एक snitch होता है. वो randomly कहीं पे भी ऊपर नीचे जाता है. And I forgot the one who collects the snitch. तो वो game जीत गया. Imagine a snitch. That's an electron, and it is randomly moving in any direction but within the sphere. You cannot predict where exactly it is placed. हाँ, but आप एक probable region बता सकते हो कि हाँ वो इलेक्ट्रॉन उस region के अंदर present है. Something similar to saying that कि JP's Academy में 11th standard JEE का lecture will be in this classroom. अब उस classroom में let's say आदि कहाँ बैठेगा is not defined, but if I want to know where Adi is, I will know that he'll be present in this classroom. On which bench, which row, I don't know that. Similarly, in an hydrogen atom, the electron is present within that spherical region, but kahan present hai, we don't really know that. And hence Neil Bohr का postulate जो था that is it is revolving in orbits. अब वो orbit का फंडा नहीं रहेगा यहाँ से. ठीक है, that is what the second point is trying to explain. Next.
So is this speculation or is it proof?
Just a second, pause करो. Okay. So the point that we wrote, people, was Heisenberg's rules out the existence of definite path or trajectories of electrons and other similar particles. Next point. The principle is significant only for motion of the motion of microscopic objects. Significant only for the motion of microscopic objects and is negligible for macroscopic objects. Next point, preferably a red pen. Thus, the precise statement of position and momentum of electrons, thus the precise statement of position and momentum of electron have to be replaced by statements of probability. That electron has at a given position and momentum. Okay, now, so we don't have the proof for this, but Heisenberg's uncertainty principle is given by, इसका derivation नहीं है scope में, delta x dot delta p, pay attention, is greater than or equal to h upon 4 pi. ठीक है, where delta x stands for uncertainty in position, delta p stands for uncertainty in momentum, and the uncertainty in momentum delta p, we know that momentum is mass times velocity. Mass can never be uncertain, so delta p can be written as m into, when we substitute that here, the expression will be delta x dot delta v is greater than or equal to h upon 4 pi and m, where we can see that what is delta v, people? Delta v stands for the uncertainty in velocity. Now let's take an example. Let's say I want to know I try to find the position of an electron, okay, to the uncertainty of 10 raised to minus 8 meters. Okay? If I substitute the value over here, delta x dot delta v is greater than or equal to h का value क्या है people? 6.626 into 10 raised to minus 34 upon 4 into pi into mass of the electron 9.1 into 10 raised to minus 31, and delta x का वैल्यू कितना लिया हमने 10 raised to minus, that goes over there. तो uncertainty in velocity कितना हो गया? This is 6.626 into 10 raised to minus 34 over 4 pi 9.1. This 10 raised to minus 8 comes here into 10 raised to minus 31. When you solve this, the value comes somewhere around 10 raised to 4 velocity at a meter per second. Now what are we trying to do? If you try to find the position of an electron accurately, the error in velocity becomes a very large number, 10 raised to 4. Why? Because I tried to find the position as accurate as possible. Getting that? And it is not applicable for large bodies because it is inversely proportional to mass. Apply to really large bodies, right hand side ka value itself is very small, negligible. Now what is momentum, people? Momentum का formula क्या लिखता है हमने? Momentum is mass. अच्छा काम करते हैं, पहले इतना कॉपी कर लो, then we'll do the second derivation. Okay, now we know that momentum is mass times velocity what I do here is I have, let's say, mass into velocity, I divide by time and I also multiply by time. What is velocity? Acceleration. Velocity over time is acceleration. So mass into acceleration into time. Now people, what is mass times acceleration? Force. So momentum can be written as force into time. But momentum के साथ we also have uncertainty in position, that can be written as distance. So distance into momentum can be written as force into time into distance. So distance into force into time. What is force into distance? Work. I don't know if you've done this in physics. work is nothing but energy into time, and hence distance into momentum can be replaced by energy into time, और the expression, हमने कैसे expression लिखा था, delta x dot delta p is greater than or equal to h upon 4 pi. This expression can also be written in terms of energy and time in the form of delta E dot delta t is greater than h upon 4 pi. This is in terms of energy and time. So, copy this for me. Okay, students. So, for the offline students, we did some numericals. Next class, we start with the wave mechanical model of the atom. Thank you.